Hello viewers, in today's class we are going to take up a very important application of sandwich theorem. So before taking up the application, let us first take the statement of sandwich theorem. So sandwich theorem is an important theorem in limits, and it says that if f, g and h be any three real functions of x such that f of x is less than or equal to g of x and g of x is further less than or equal to h of x for all x in the common domain, and then for some real number, a, if limit x tends to a of f of x is L, and limit x tends to a of h of x is also L, then the limit x tends to a of g of x is also equal to L, right? So sandwich theorem says that if we have three functions of x, f, g and h, as f of x is less than or equal to g of x and g of x is less than or equal to h of x for all x in the common domain, then for any real number a, if limit of f of x when x tends to a is L, and limit of this function when x tends to a is L, then the limit of this function g of x which is sandwiched between f and h is also L, right? So here we see that the function g is sandwiched between these two functions f and h, and if the limit when x tends to a of f of x is L, and the limit of this function h of x is also L when x tends to a, then this theorem says that the limit of the function which is sandwiched between these two functions, which is g of x, then the limit of this function when x tends to a is also L, right? Now using this sandwich theorem, let us prove an important result. Now let us take this trigonometric inequality. So cos x is less than sin x over x is less than 1 for x greater than 0 and less than pi by 2. So we'll prove this trigonometric inequality, and when we'll apply sandwich theorem to this inequality as x tends to 0, then we'll prove that limit x tends to 0 of sin x over x is equal to 1, right? So here we'll first prove this trigonometric inequality, and then applying the limit to this inequality when x tends to 0, we'll make use of this sandwich theorem, and we'll prove that limit x tends to 0 sin x over x is equal to 1. So let us first prove this inequality. So the proof, it goes like this. Now let us take a circle whose radius is OA, and suppose after some time we take the point C and we join OC, right? So here we have a circle whose radius is OA, and we take a point C on the circumference of the circle so that uh, we have the arc AC, right? Okay, now we extend OC such that when we join this point, right, we extend OC to this point B such that this BA is perpendicular to OA, right? Okay, now what we will do, we'll join the point C and point A so that we get the chord CA, right? So here we have to join this point C and A. Clear? Okay, so here we have a circle with center O. We take 2 points on the circumference of the circle as A and C. We join OC and OA, and we extend OC to the point B such that when B is joined to A, BA is perpendicular to OA. It means angle OAB is 90 degrees, right? So it is pi by 2. Okay, now we join the point C and point A, so we get a chord CA. Now here what we will do, we'll drop a perpendicular from point C to this radius OA. So if we drop the perpendicular like this, let us say this point is D. So we have angle ODC is 90 degrees. Clear? Okay. Now the angle AOC, right? Suppose this angle is X. Clear? So angle AOC can be taken as X radians. Clear? Okay. Now here we see that this angle X is obviously it is greater than 0 but less than pi by 2. Clear? So we have this condition. So X is greater than 0 but less than pi by 2, and we can take this circle as a unit circle, So X is in radians, and this X is in radians, and if we take this circle as a unit circle, then we see that OA is equal to OC and it is equal to 1 unit, right? Okay, now using the concept of area, we see that area of triangle OAC, right? OAC is half base multiplied the altitude. So we have half multiplied OA multiplied CD, right? Because the area of a triangle is half base into altitude. Okay, so this is the area OAC, area of triangle OAC. Clear? Okay, now let us find out the area of sector. The area of sector OACA, right? So we have the sector like this. So this is O, this is A, and this is C. Clear? So the area of the sector is given by pi r square theta over 360 degrees, right? So we can write for 360 degrees, we can write 2 pi. So the area of this sector can be written as pi times r square. R square is the radius, so we have pi times OA square, and then we have for theta we have x, and divided by 360 degrees, and for which we can write 2 pi, because pi radians is equal to 180 degrees. Clear? And then we have to find the area of the triangle, OAB. So the area of triangle OAB is again half base into altitude. So this is the base is OA and altitude is AB, right? So the altitude is AB. Okay, so viewers, here we have a unit circle. We have 2 points on the circumference, A and C. Then we have joined OC, OA. We extend OC to the point B, and we join B to A such that BA is perpendicular to OA, right? Now this triangle is divided into different areas. So first we have calculated the area of the triangle OAC, which is half base into altitude. Then we have calculated the area of the sector OAC, which is pi r square theta divided by 360 degrees. So we have pi times radius is OA, so OA square times for theta we have x, and divided by 360 degrees, which is 2 pi radians. And then we have the complete triangle, that is triangle OAB, and the area is half base times altitude. So we have half OA times AB. Clear? Now let us denote the area of triangle OAC by A1 and the area of the sector by A2 and the area of the triangle OAB as A3, right? So we see that, or it is quite evident from the figure, that A1, the area of triangle OAC, is less than the area of the sector, and the area of the sector is less than the area of triangle OAB. So we have the inequality A1 is less than A2, A2 is less than A3, right? So now here we see that OA is 1, that is 1 unit. So we have, if we substitute OA equal to 1 here, we get half CD. Clear? Now here pi and pi get cancelled, and OA is 1 unit, so we have 1 square is 1, so we are left with only x over 2. Clear? Okay. Now here OA is 1, so we are left with half times AB. Clear? So this is half times AB. So if we substitute the values of these areas in this inequality, we get a half of CD is less than x by 2 and less than half of AB, right? Okay, now we see that the factor 2 occurs in all the terms. So if you multiply the entire inequality by 2, we get CD is less than X and it is less than AB, right? So this is an important inequality, right? Okay, now we have to find the value of CD, right? CD from the triangle ODC. So we see that in triangle ODC, if we apply the trigonometric ratios to this triangle, so we have sine of x can be written as CD divided by OC. CD is perpendicular, OC is the hypotenuse, and OC is 1 unit, so we are left with only CD divided by 1, so we have sine x is equal to CD. Clear? So we can substitute sine x here for CD. Clear? Okay, so we have x here. Now we have to find the value of AB in terms of x. Clear? So what we will do, so again we'll take the triangle OAB and we'll take tan of x. So tan of x is perpendicular divided by base, so we have AB divided by OA. Now OA is 1 unit, so we have AB over 1, so AB is equal to tan x, right? So we can substitute the value of AB as tan x here. So this is an important inequality, that is sin x is less than x, x is less than tan x whenever x is greater than 0 and less than pi by 2. Now we can write this as sin x less than x. For tan x we can write sin x divided by cos x. Now sin x is positive. Sin x is positive in the first quadrant because x is greater than 0 and less than pi by 2. So we can divide both sides or throughout by sin x. So this sin x get cancelled, so we are left with 1. Then we have x over sin x because we divide the entire inequality by sin x because sin x is positive in this interval. So we have x over sin x, and here sin x get cancelled, so we are left with 1 over cos x. Clear? Now taking the reciprocal throughout, we get cos x is less than sin x divided by x and less than 1, right? So here in this inequality, if we take the reciprocal, then the direction of the inequality gets reversed, and so we have cos x less than sin x over x, because here we'll have the reciprocal sin x over x, and this is 1 over 1, so we'll simply have 1, right? This is 1 over cos x, so we'll have cos x over 1. So this is how we have proved the trigonometric inequality whenever x is greater than 0 but less than pi by 2. And here always remember that x is in radians. Clear? So now we'll derive an important limit using this inequality. So now we'll prove this limit, that is when x tends to 0, limit x tends to 0, sin x over x is equal to 1. So we have just proved that cos x is less than sin x over x less than 1. So now taking this limit, now taking limit x tends to 0 throughout this inequality. So we'll get limit x tends to 0 cos x less than limit x tends to 0 sin x over x, and then we have limit x tends to 0 1. Right? Now we see that in the sandwich theorem we have just seen that if f is less than or equal to g, and this is less than or equal to h, and for any real number a, limit x tends to a of f is L, and limit x tends to a of h is also L, then this shows that the limit of this function would also be L, right? So this implies that limit x tends to a of g is also L, and g is sandwiched between f and h. So here if I take cos x as the first function, f of x, let us take this function as g of x, and this function which is a constant function, and let us take it as h. Clear? So we see that this limit, that is limit x tends to 0 of cos x. So when x tends to 0, so this limit becomes cos of 0, and cos of 0 is 1, and this limit, that is limit x tends to 0 of 1, is simply 1. So these two limits are same, because this is limit x tends to 0 of f, this is limit x tends to 0 of h, and this function g is sandwiched between f and h, right? So by sandwich theorem, the limit of this function g is also 1. So it implies that limit x tends to 0 sin x over x is equal to 1. So this is how we arrived at this result, right? So viewers, today we have discussed a very important consequence of sandwich theorem, and we have proved this inequality, and using this inequality and sandwich theorem we have proved this important trigonometric limit, right?